Hello.
This was on the floor.
This was on the floor. Oh,
From the
cool.
previous.
Yeah, cool. I will just leave it here because they're coming back here anyway. Thank you very much. Shall we make a start? Yeah, we make a start. Most wonderful good afternoon, ladies and jelly beans. Have you had lunch? Yeah, see, good. That's. So, welcome to our sort of revision session on Potions 101. And I thought, I'd just greet you with a picture of this young gentleman. And I don't care if you object to be called a jelly bean. Obviously that's the Count Avogadro. With a profile picture like that, I'm not surprised that nobody has taken his number. But I don't want to be unkind. It's just one of the numbers that you unfortunately have to remember, but you probably know that anyway quite well. So, what I want to do with you today is just a little bit of recap about some topics that unfortunately you will not be able to escape. This is the stuff that is your that's the stuff that is your bread and butter. I'm terribly sorry, and it will follow you wherever you go as a bioscientist. So we better get that right straight at the start. So let's talk a little bit about mole and molarities. And quite a number of people, especially when it comes to their final year, they tell me, oh, I never got mole. I never really understood what it means. And I thought, holy shoot, where did we go wrong? Right? Now, moles, and I don't mean the things that live in your garden and dig it up. That's different mole. Yeah? Moles that we use, I just said that. No need to put that on the on the chat. But anyway, mole is just another expression for a very common number. Mole is nothing else but a number. And in this case, it indicates Avogadro's number, 6.022 times 10 to the 23. Now, conceptually, just think of it as a simple expression. What do you call 2? It's a pair. Yeah? Pair. What do you call 12? Dozen, exactly. What do you call 13? A baker's dozen, exactly. Why is it called a baker's dozen, by the way? Say loud.
They cook 13 bread rolls in case one was burnt or oversized.
So one of the theories why it's called a baker's dozen, 13, is that, as you said, is they made 13 just in case one burns. Actually, it's a little bit more, the version that I know, it's a little bit more sinister. And that is because bakers were known as people who cheat and commit fraud. Because you delivered the flour and they made the bread. How easy is it to just diddle you out of the flour a little bit, get some for yourself, and deliver a smaller loaf of bread or a few less rolls. And therefore, this was heavily punished. Bakers were heavily punished if they were found cheating. And therefore, they decided, well, it's better, rather getting flogged, we just make one more to show that we are honest people. I have no view on that. Okay, that was 13. What is 12 of a dozen? 144, of course. What is it called? Has a name. It's a gross. 112? No, it doesn't have a name. And, of course, 6 times, that is just another name for just a number, right? Oh, here's one interesting. A short form for a very, very big number. And you probably make a link now between this number and something else. What is this called? 10 to the power of 100. Allegedly, this is the number of atoms in the entire universe. How they found that, I don't know. I don't think anyone has counted them. But what is this called? It's a big number, obviously. Anyone? A Google. Exactly. Spelled slightly differently, but you see, can you make a link? The enormous amount of information that a certain company holds and the name, Google. How cool is that, hey? So, a mole is just a number of particles, a number of entities, or whatever. You can even have a mole of moles. So if you've got 6.022 times 10 to the 23 little animals digging in your garden, that would be a mole of moles. I doubt that there are that many moles around on this planet, but theoretically it is possible. You can have a mole of moles. Now, having cleared that, mole is just simply an amount of something. What's molarity? Well, molarity is just simply an amount per volume. Or in other words, molarity indicates a concentration. So I could, for example, say we have (249) people in this room. So 249 people per room. Is there a concentration? In a way it is, because we have an amount per volume. Volume is the room per 100 cubic meters or something like that. I don't know what the volume is. So mole indicates amount, molarity indicates concentration. If you get that, you can't lose any longer. Right? You will get things right. Unless some of our final year students who say, I don't know, I never understood molarity. Okay. Now, with this out of the way, we just need one more concept, and that is just simply brings us back to chemistry. Sometimes we need to know how much a certain amount of molecules or atoms actually weigh. And most of you have probably, no, I know that all of you have seen that because that is pre-GCSE. So, going back to chemistry, you have seen something like that. 12, 6 carbon. Have you seen that?
Yeah.
Yeah? Or 2, 3, 2, 9, 2. Uranium, exactly. Well done. Now what this tells you is basically, this number down here tells you the number of protons that are located in the nucleus of this element. That is sort of the ID of this element. So uranium has 92 protons. This guy here, this 232, this number has two meanings. One meaning is it tells you how many particles in total are in the nucleus. So this is the number of protons plus neutrons. So taken together. How many neutrons does this particular isotope of uranium have? About 140 neutrons. So this guy has 92 protons and 140 neutrons. And together it gives us 232. But this number also tells us a little bit more. It tells us that 1 mole of this isotope of 23292 uranium weighs exactly 232 grams. Okay? So that is what you can figure out from this number. 1 mole is equivalent to 232 grams. So let me write that down. 1 mole equals 232 grams. I can also write this as 232 grams equals 1 mole. And you probably go now, WTF? Why is he pointing that out? That's absolutely self-evident. I can read it from both sides. There's a little trick to it. And we come back to that little trick in a couple of minutes. This one here I can write as 1 mole per 232 grams. This one I can write as 232 grams per 1 mole. It's exactly the same, isn't it? Totally the same. And I don't do any dirty tricks. I don't do any magic or anything like that. Not today. Yeah? Although I could show you a really cool magic trick. Let me show you that. You'll get it back, don't worry. See that? Just the tip of the pen. Wow! So Harry Potter is back. Sorry about that. Has nothing to do with. Were you scared? Has nothing to do with that topic. Right? It was good, yeah. Thank you. Okay, sorry. Now I want you to remember that we can write things in different ways. Right, now here's a question for you. I have, what was that? I think I turned that off, huh? The group chat. It's distracting. Well, the good thing is I know very easily who said things, so if somebody says something I totally disagree or disapprove, they will get a bollocking afterwards. Okay, now we have all that we need in the first place. Okay, I have a substance which has, let's say, a molecular mass and this thing here, 232 grams per 1 mole, that is in general known as your molecular mass. Yeah? Often abbreviated as MM or sometimes MW for molecular weight, or yeah, that's basically it. So molecular mass, we have a substance, molecular mass of, say, 100 gram per mole. And I have $12 grams of this substance. How many moles are that? Sorry? You do cross multiplication? Everybody gets that?
So, are you looking at 12 grams of the 100? How many moles?
Do you know the equation by heart for that?
Amount equals mass divided by molar mass.
So amount, let's say, if I can, amount equals mass divided by molecular mass. Probably. Tell you what, I am absolutely lousy at remembering equations. Why? There's a very simple reason. My life is too short to waste my time trying to remember this stuff. There are far more interesting things to do in life. I can watch football. I can play with my dog. Netflix. I didn't say and chill, okay? So I would not necessarily occupy my brain with something like that. There is a very simple trick how you can derive equations on the spot. And if you get this trick, you don't have to remember a single equation, at least not for me. Well, it's not true, but. So, what is this trick? The trick is, instead of remembering equations, I just simply work with units. So, what do I mean? Well, we have something here. So let me write out the question in the first place, okay? substance has molecular mass of 100 gram per mole. I have 12 grams. How many moles do I have? That's the question. So, my approach is I am guided only by units. So what units do I have? First of all, I have units here, I have units here. And I have a unit in my question, in the moles. So what I always do is I say, right, what is the unit that I want, that is in my question? And I write that down. Mole. That's this guy here. Mole with an E and without E is usually sort of equivalent, so don't worry too much about it. If it is in a unit, it's usually without an E. If it is in a different context, then it's usually with an E. Don't worry too much about it, right? Okay, that is the unit that I'm looking for, mole. No, we don't do that with that. Sorry. Just let's forget this thing. So, in my things that I have given, here and here, do I have anything with mole in it? Yeah, which one? Sorry, the molecular mass, exactly. So what I do now is I write it in such a way that the one that I'm looking for, the unit that I'm looking for, is basically on top of a line. So this means I can write it as 1 mole per 100 grams. And we said 100 gram per mole is exactly the same as 1 mole per 100 grams, isn't it? It means exactly the same thing. Yeah? So I write it in that way. 1 mole per 100 grams. Okay, got that so far? Now what I see immediately is that I have my unit of mole that's nicely in place. That is exactly what I want. But what's annoying is that we have this 100 gram down there, if you like, in the denominator. Right? So how do we get rid of this thing? Well, what we can do is we just simply try to cancel the grams out with something in our other given. Do we have something with gram in our other given in our question? What, you're nodding? What is it?
12 grams.
12 grams. So if I write this now as times 12 grams, what will happen to the grams, to the unit gram? They cancel out. Look at that. Wow, cool. Well, so what have I got left? I have got, and I just write it in a nicer way, I have 12 over 100. And the unit that's left, what is the unit that's left? Mole. Exactly. So I have 12 over 100 mole. Is that the same that you proposed? Absolutely, it's the same thing. But I didn't have to remember anything. So if you work with units and are guided by units, you don't have to remember any equations. How cool is that? I know, however, that a lot of people have learned, for example, what you said, you know, amount equals, mole amount equals mass divided by molecular mass or something like that, yeah? Was that right? Or you had this triangle. Did anyone do that with a triangle? You did, yeah? So you had gram, you had here mole, and you had here gram per mole. Is that right? Have I done it right?
Yeah.
Yeah? Now, truth is, whichever way you do it, I don't care. Do it whatever suits you best. You ain't getting penalized if you do it in a particular way. You only get penalized if you get it wrong. So, if you want to learn your equations, fine with me. If you want to do a triangle, fine with me. If you want to throw runes to get it right, fine with me. As long as you get it right, I don't care. I will usually use the what is called the dimensional analysis method because, as I said, it's cool, it's quick, I don't have to think. Thinking is bad. Right? But it means that you have to pay attention to units. So it's what I always find myself writing on scripts, on exam scripts. This is when people totally abuse units. This is a crime. Let's face it. Yeah? There is all of a sudden there's a number turning up. No unit. Could be anything. Could be grams per mole. It could be moles per gram. It could be turkeys eaten at Christmas. Yeah? It could be anything. So units are absolutely essential. Don't abuse, don't discard units. They are absolutely essential. They are a little bit like, almost like when you go clubbing and there's no music, right? This sucks. So a number without a unit, that sucks too. That's even worse than clubbing without music. Right? And it can have disastrous consequences, not just for your exam scripts. A few years ago, NASA and the European Space Agency, thank you, they were working together to send a probe to Mars. Everything went well. We had liftoff. 8 months later, the probe missed Mars spectacularly by several 100,000 miles. And you think, flippin' heck, how's that possible? You know, Mars is not just a sort of a dust grain, it's a big planet. How on earth can you miss a planet? Well, the answer is very simple. NASA measured everything in kilometers, whereas the European Space Agency, which was then under the jurisdiction of the UK government, they measured everything in miles. And of course, they forgot to tell each other what units they used. 150 million pounds worth of equipment is just now, is now drifting towards Saturn. No purpose. Had they given me 1/10 of it, of that money, oh boy, I would be happy. Right? So, units. Units, absolutely essential. Without units, nothing goes. Okay? Happy with that? Now, of course, we can do a lot more with something like that. We are not just restricted to, let's say, where has it been? Oh yeah, with two things here. It's just two components in our equation. Let's do something a little bit more demanding. Let's make some potion. Hey, how cool is that? One of the most common things that you will encounter is you have to make up a solution. Okay, make solution. You have Hech? No, you can't have my potion. Sorry, mate. Let's make a solution. Okay. Substance has molecular mass of, let's say, again, let's do 100 gram per mole. We want to make 100 milliliter of a 0.1 mole per liter solution. How many grams do I need? How many grams are required? Of course, you can use your equation. Yeah? No problem. You can use your triangle, although you will find it quite difficult with a triangle in this case, because in the previous case we had only two things in the equation, and you had to use 2 dimensions. Now you would have to do 3 dimensions. You have to pull out the triangle, right? Not that easy. Shall I show you my way? Of course, because otherwise I wouldn't say that, and you have no other option but listen to me. So, what is the unit that I'm looking for? Loud? Grams. So I write grams down. Do I have anything that has grams in it in my givens? Yeah, which is?
100.
What?
100.
What?
100.
What?
100 grams per mole.
Ah, thank you. Thank you. Oh, there's another one. Is that yours?
No,
That's yours. Oh. No, I've shown you that. So, we have 100 grams per mole. Note, I write it in the way that the grams is on top of this, of the fraction line. So gram and gram are in the right position, right? How cool is that? I don't have to worry about that. Now, grams are good, but I have these pesky moles down in the denominator. Do we have anything with moles? Yeah, which is 0.1 mole per liter. So I just multiply it. Yes, do that. Put me in your music video. So I just simply write it so that the moles cancel out. 0.1 mole per liter. You see what happens to the moles? What happens to the moles? Hasta la vista. Unfortunately, I have another problem now. Can you see the problem? That's the liters. Merde. So I need to get rid of the liters. Do I have anything with liters in it? I have the 100 milliliters times 100, but now I have another problem. I have the milli. So I need to convert that, because I can only deal with the same units. Right? So let's quickly go a little bit through the different units and then come back. So what does milli mean? One times 10 to the negative to the power of minus 3, which is the same as 1 over 1,000. Okay? So 1 times 10 to the minus 3, that's milli. One times 10 to the minus 6, what's that? Micro. And that's usually abbreviated with this Greek letter mu. So that's micro. Ten to the minus 9. Nano. Oops. Go back. Nano. Ten to the minus 12. Loud? Pico? Yep, you're right. It's pico. Ten to the minus 15. Femto. Minus 18. Atto. Ten to the minus 21. Check it out on Wikipedia. Okay? What you really need to be comfortable with is this part here. Milli, micro, and probably nano. The rest is sort of, your party trick. Okay, so don't worry too much about those. Now let's go back to our previous question. So we said we have 100 milliliters. And I can write this as 100 times 10 to the minus 3 is 10 to the minus 3, that's the milli. Loud, what was it?
Septo.
Septo and?
Yocto.
Yocto, exactly. So 10 to the minus 21 is septo, 10 to the minus 24 is yocto. Just in case, you know, you want to impress your housemates. So we have 10 to the 100 times 10 to the minus 3 liters. And now watch the magic. The liters cancel out as well. What have I got left? I have only left my grams. And what do I want to have left? I only want to have left my grams. So I can now stop. I don't have to cancel out anything else. So this is 100 times 0.1 times 100 times 10 to the minus 3 gram. And if you do that, let me just quickly do that in my head. This is 1 gram. Did you get it? How easy is that? How cool is that? Okay. Let's say we have molecular mass of 66,000 gram per mole. $66,000 gram per mole. This usually indicates that if something is that heavy in molecular terms, very often people abbreviate that with something completely different. They say it has 66 kilodalton, kDa. Kilodalton just simply means kilo means 1,000. And Dalton is sort of, again, a unit for molecular mass. So 66,000 gram per mole is the same as 66 kilodalton. And people who work with proteins, for example, are far more comfortable with something like that, 66 kDa, kilodalton. You will hardly ever hear somebody working with proteins saying, oh, this protein has a molecular mass of 125,000 gram per mole. They just simply say it's 125 kd. Right? So you're just so that you know. So we have a molecular mass of 66,000 gram per mole, or 66 kilodalton. We want to have 1 millimolar, 1 millimole per liter solution. And we want to have 100 milliliter of that. Usually I write it down in my lab book like that. It's not very nice, but obviously you understand what it means, right? So how many grams of this protein are required? Do you want to try it yourself? Yeah? Give it a go. Let's see what you get. I appreciate the invitation to club chemistry, but I'm not coming, sorry. Discuss it with people sitting next to you. And try it with this dimensional analysis. Shall we quickly do it together? Yeah? Okay, what is the unit that I'm after? What am I looking for? Grams. Do I have grams anywhere? Where? So I have 66,000 gram per mole. So the gram are nice, cool, I got them. But I have a bit of a nuisance. I need to get rid of the mole. Do we have mole anywhere? Where? 1 millimole per liter. Now let's write this in the converted version, because I can't deal with the millimole. It has to be mole, so that I can cancel it out. Times 1 times 10 to the minus 3 mole per liter. Yeah? Happy with that? That is my 1 millimole per liter. What happens to the mole? I would like to say that in an Arnold Schwarzenegger's Austrian accent. Hasta la vista, baby. Right, it goes. But I created another problem. So I need to deal with the liters. Do we have anything with liters? We have the 100 milliliters times 100 times 10 to the minus 3, that's the milli. Don't forget the milli. Liters. What happens now? Liter and liter cancels out. How cool is that? And now the rest, that is something for the mathematical pedestrians. So I've got left 66,000 gram times 1 times 10 to the minus 3 times 100 times 10 to the minus 3 equals Loud? 6.6 grams. Was that easy or was that easy? Yeah? So now you are better than many of the final year students, because for you now it is just a matter of practice a little bit. Yeah, that makes sense? Just a little word of warning for our friends from the continent. We haven't achieved Brexit yet, so you still have to deal, we have to deal with all things UK-wise. For our friends from the continent, please note that in the UK way of writing, this decimal is a point. What do people from the continent, including myself, I used to do that, what do they do? It's a comma, right? And any halfway educated UK citizen would read a comma as 1,000. So if you mean decimal point, please put in a decimal point. Don't put a comma. Okay, can we agree on that? We are very close to getting everything done. I suggest we have a 5.7-minute comfort break and then reconvene, and I show you 2 more things related to potion making. Okay? Happy with that?
To mess this up, because when I did that, I either got 100 times 100 is 0.01,
okay,
which is not 1. So I'm just wondering if I can mess up the units.
So we have 100 milliliter of a 0.1 mole pill.
Yeah.
So you would need to convert this into 100 times 10 to the minus 3.
Which is 0.1.
Yes, absolutely. 0.1 times 0.1 times 100. Try this. 100 times 0.1 times 0.1. 1.
Yeah, I was just trying to do it like I used to do it in this, and it didn't work. So I was a bit confused.
That's a bit of a bummer, huh? Sometimes it doesn't work with a triangle.
Yeah.
Hiya, is there going to be like a worksheet with like stuff for this to practice on like Moodle?
Oh, I will send you something.
You will send us something. Oh, that we'll be able to like apply this to.
Absolutely. Absolutely. I will send you quizzes.
You will. Oh, you will send us quizzes. Oh, okay. Is the rest of the thing going to be on moles?
It will be an percentage solution.
Percentage solution.
Have you done that?
I did it at A level, yeah.
Okay.
I've still kind of.
And the rest is how to make dilutions.
I did that in A level as well.
What are
it
you
wouldn't
doing
hurt
here?
your feelings if I.
God, no.
Okay, okay. Yeah.
I don't have any feelings.
Oh, you right. Oh, okay.
I have no feelings. Oh, by the way, just a quick announcement. I've just had a discussion with a gentleman who said, he had done all of that stuff at A level, and whether it would hurt my feelings if he's going home now. And I mean, to be perfectly honest, I don't have feelings. So you can't hurt nothing, right? If you feel that this is just, too easy, too simple, I can't say it loud, right? But don't feel that you have to be here for my entertainment. Okay, so if anyone wants to go, please do feel free. I don't take it personally.
So,
I understand your way of doing it. I have always done it before. I seem to have confused myself somehow. So, if I explain my logic, maybe you
There's a
can tell
zero
me.
missing.
Thank you.
You're welcome. That was easy, wasn't it?
I'm sorry, I'm a little bit confused on why we've times by 100 and then by the moles again.
Okay, so we said we have 100 milliliter. 100 milliliter.
Oh, okay. Alright.
Penny dropped?
Yeah. Okay, thank you.
Okay, can we come back, please? And before we commence with the potions, can I ask you all, just for a moment, now it's going to be tricky, can I ask you all to stand up for a moment, please? Wonderful. And now sit down again, please. I just want you to get the blood circulation a little bit going, because otherwise all your blood is down in your backside and not in your head. And if you've got too much blood in your derriere, you just get piles. right? So, right, there are two more things that we need to do, and then I release you. Is that your last lecture today? Yeah. And then I release you into your well-deserved weekend. But what I will do is, in my next email, I will send you links to exercises where you can practice these things, right? Because that is what it's all about. Practice, practice, practice. Practice makes perfect, okay? Right. One thing that you sometimes, probably quite frequently actually, will come across is when we don't know exactly the molecular mass of a substance. So far we've said, you know, we might have molecular mass of, oh yeah, let's quickly do glucose. So glucose is C6H12O6. It's made up of 3 elements, 12,6 carbon, 1 hydrogen, and 16,8 oxygen. Now we are dealing with something that is made up of more than one kind of element. But in order to get the molecular mass of the glucose, all we need to do is just simply add up and use the stoichiometry Wow. Sometimes I have that, you know, I hear sounds, I hear voices. What really bothers me when the voices stop. Then things get a little bit tricky. Anyway, what we can do is, just simply from these data, we can easily figure out what the molecular mass of glucose is. All we need to do is add these things up. So we have 6 times 12 for the carbon. For the hydrogen, we have 12 times 1. And for the oxygen, we have 6 times 16. And if you sum that up, what do you get? 180. So the molecular mass of glucose is 180 what? Grams per mole. You learned something. Never do anything without units. Oh, and I think I probably need to refresh quickly because it gets a little bit fuzzy. Yep, we're back in business. So it's quite easy to figure that out. But sometimes we don't know exactly, particularly if it is an unknown or uncharacterized substance, we don't always have the molecular mass. So does that mean we can't make a solution of that? Oh, no, we can. We just simply say, actually, we could do our solution. We can have a concentration of, let's say, 10 gram per liter. It is a concentration, isn't it? It's an amount, the 10 gram, per volume, per liter. It's a concentration. It's just we don't have the mole in it, but we know that mole is an amount, the grams also represents an amount. So that's a perfectly valid concentration as well. 10 gram per liter. We don't need the molecular mass for that. Sometimes you see it as 10% weight per volume. Whew! And a lot of people, when they see that, a lot of final year students, you really see the adrenaline kicking in. And it's not good adrenaline, it is panic. Shit, what am I going to do? Right? 10% weight per volume. What on earth does that mean? Well, what does percent mean? I heard, sorry, say? Out of 100. Per, out, centum, 100. Out of 100. So 10% actually can be easily translated into 10 gram, we need a weight, per 100 volume milliliter. Yeah? So 10% weight per volume is 10 gram per 100 milliliter. How many grams per liter is that? Bingo. 100 grams per liter. It's just multiply each one by 10. Okay? Make sense? I want you to remember that because you will come across this thing. 10% weight per volume or 0.1% weight per volume. Things like that. Yeah? Sometimes you even come across as 5.4% volume per volume. Anyone seen that before? So usually you find that on your beer bottle. Yeah? It just simply means 5.4 volume, milliliter of alcohol per 100 milliliter total volume. 5.4% volume per volume. So that means a liquid in liquid. Okay? And you will get questions about that. Now, question, do you have any questions at the moment? Clear as mud. God, I'm so good. I'm so pleased with myself. One last thing that I need to do with you, and that is dilutions. Very often you will find that you have made up a solution already, or solutions have been made up. So and this solution, that is just something that you work with. Or rather, that has been provided. This thing is called a stock solution. That's a solution that has been made up. For example, a stock solution has a concentration of, let's say, 1 mole per liter. It is highly concentrated. By the way, instead of mole per liter, I could also abbreviate that with a capital M. It's the same as 1 M, 1 capital M mole per liter. It's the same thing. Do me a favor, please don't write it as 1 lowercase m, because that indicates it's a 1 meter. Meter and mole per liter is a different story, right? It gets particularly interesting if you have millimeters, when people indicate that as millimole per liter. Don't do that. Do a capital one. So the stock solution, we have a stock solution, which is highly concentrated. And what we actually want is a working solution. Exactly. And the working solution is less concentrated. So, for example, our stock solution, as I said, stock 1 mole per liter. And we want to have 100 milliliter of 0.1 mole per liter working solution. How do we have to think about that in the first place? Here's our stock. One mole per liter. And we want to have 100 milliliter of a working solution. Which has a concentration of 0.1 mole per liter. Okay? So we have to take something out from the stock solution and make up our working solution. But how much do we have to take out from the stock? How can we deal with that? There's a simple trick. It's a very simple trick. First of all, I show you the long way, and then I show you the short way. The long way is how many moles do we want to have in our working solution? How many moles do we want to have in there? Can we calculate that? And we do dimensional analysis. How cool is that, huh? So we say, what is the unit that we are looking for? Moles. Do we have in our givens here anything with moles? Loud? Mole per liter. So we have 0.1 mole per liter. That's this guy here. So the moles are in the right place. Great. I have to deal with the liter. Need to get rid of the liter. Do I have anything with liter? Times 0. No, sorry. Times 100 times 10 to the minus 3 liter. That's my 100 milliliters here. Yeah, you see that? What happens to the liters? Hasta la vista. I love it. I love the Terminator. So, how many moles have we got? So I need 0.01 mole. Right? Makes sense? Have I got it right? Ha! I can do that even without a calculator. What a man. So, what does this tell me? It tells me I want to have 0.01 mole. I need to pick 0.01 mole from my stock solution. I need to get 0.01 mole from my stock solution and transfer that into the working solution. Make sense? Yeah? Okay. So, how many milliliters is that? How many liters is that? So I have a 1 mole per liter stock. I want 0.01 mole. How many liters is that? Shall we do dimensional analysis? Because we haven't done that before, have we? Okay, what's the unit that I'm looking for? Liters. Do we have liters? I have to write it in a different, you know, the upside down version, as my friends from Scotland would say. So it would be 1 liter per mole. It's the same thing. Liters in the right place, but I need to shoot down the mole. Do I have anything with mole? Yeah. Times 0.01 mole. I've seen people in an exam do that. They went and everybody was, oh shoot, that's a weirdo. But if it helps, mole cancel out. So what I have is 0.01 liters. Make sense? I can convert that into something nicer. I could convert that into milliliters, can't I? Looks nicer. How do I do that? Milli is divided by 1,000. So if I divide this by 1,000, then I get this into milliliters. No, divide that, multiply it by 1,000, that's the one. So that would give me 10 milliliter. Yeah? Now this means 10 milliliter of the stock contain 0.01 mole, and that is exactly what I wanted. Yeah? So, I want to take 10 milliliter of the stock, and that is exactly what I need, 10 milliliter of the stock, because this has exactly the amount of moles that I need in my working solution. Now I've got 10 milliliter of the stock. I want a total volume of 100 milliliter here. So I just take these 10 milliliters and add, for example, 90 milliliter of water. And I've got my 100 milliliters with the 0.01 mole that I want. That was quite shocking. You dropped your cup again. Right? That was the long-winded way. Does it make sense to you? Now, just in case you wonder, you can do it much faster. Because what I just showed you is actually the principle of a very famous equation that probably everybody of you remember. Have you seen that equation? C1V1 equals C2V2. A lot of people have seen that. Those of you who haven't done chemistry, it is just the abbreviated form of what we have done in the last 10 minutes. It means concentration of stock volume of stock equals concentration of working. I just abbreviate that if that's okay, yeah? Concentration of working solution times the volume of the working solution. Okay, get up and dab everybody now, because you've just seen that, and we make this person very, very poor. Everybody up? Come on, let's get up. Let's get up. This person has offered a $5 to everybody who gets up and dabs. Go on, dab. Okay, thank you. Right, we will put up, has everybody dabbed? We will put up a collection next time and I'll tell you who it was, right? So with this, C1V1 equals C2V2. Be careful what you wish for. This is a very, very useful equation when you have to dilute things, right? But this approach with the moles, that will always help you. Somebody has the computer on speaker. Okay, good. Right. Now this thing with the moles, that always works. C1 V1 equals C2 V2. That is the underlying principle. Or the moles is the underlying principle of this equation. My version is a little bit more, how shall I say, idiosyncratic. Okay, we say, normal people say stock solution C1 working solution is characterized by C2 and V2, volume 2. Whenever I see that, I have this picture in my head of a pharmacy. Pharmacy. A guy comes into the pharmacy with a prescription in his hand. And on this prescription, the doctor says, this person is really poorly, give him some medicine. I want this person to have V2 amount of concentration. Right? This is what the guy has in his hand. And then you can see here, here's the counter. And there's the hot pharmacist. Big smile. You can tell my drawing skills are a little bit limited, but never mind. And the hot pharmacist says, sorry, what did you say? Yeah, the plague doctors, exactly. I mean, I could try to make this pharmacist a little bit hotter, but then I might be in trouble with, with the head of school and things like that. Inappropriate teaching. I might. So anyway, the hot pharmacist says, I'm terribly, terribly sorry. We only have our stock with that concentration C1. That's my picture that I have. So how does that help you? Well, look at that, what I just done. V2 times C2 divided by what the pharmacist has, C1. And that is the required volume. That's the required volume of the stock solution. So V2 times C2 divided by C1 gives you the required volume. Simple as. And I'm pretty sure you all have seen a hot pharmacist. No? They're not hot. Oh, that's I mean, have you been to Sainsbury's here? I mean, to be perfectly honest, I wouldn't recommend it, but, Anyway, that's my picture for it. And that tells you how to do dilutions. So all you need to do now is really practice. And I will email you some practice questions. How is that? Are you happy with that? May I suggest now that we all go home? Yes? See you next week.
Just one question.
Yes.
In terms